Hi, this video is about endothermic and exothermic reactions. There is more content, quizzes and past papers on the website, which is www.elevise.co.uk. So let's get started. The substances that are reacting together in a reaction are known as the reactants. The substances that are produced are known as the products. For example, if we looked at the respiration reaction, we will see that glucose is reacting with oxygen to produce carbon dioxide and water. Glucose and oxygen in this reaction are known as the reactants because they're the substances that are reacting together, and the products, which are going to be the substances that are produced, are carbon dioxide and water. Whenever a reaction takes place, changes in energy will occur. There are two different types of reactions. These are endothermic reactions and exothermic reactions. Endothermic reactions take in energy from their surroundings. They usually take in energy in the form of heat, which will usually show a fall in temperature of the surroundings. The other type of reaction is exothermic reactions. Exothermic reactions give out energy to their surroundings. The energy that they give out is usually in the form of heat, and as the heat is given out, there will be a rise in the temperature of the surroundings. The easiest way to remember the difference between endothermic and exothermic reactions is to look at the beginning of each of the words. With endothermic reactions, the beginning is N, and think of this as in, so think energy is going into the reaction. With exothermic reactions, the beginning of the word is X, so this is similar to exit, so think that energy is exiting during the reaction. We are able to draw reaction profiles for any type of reaction. From the reaction profile, we'll be able to see if the reaction is endothermic or exothermic. The reaction profiles show us the amount of energy in the reactants, which is the substances that are reacting together, and the amount of energy in the products, which are the substances that are produced by the reaction. A reaction profile also shows us how the energy changes during a reaction. From the reaction profile, we can work out what the activation energy is and what the overall energy changes. The activation energy is the amount of energy that is required to kickstart the reaction. It is the difference between the energy of the reactants and the highest point on the reaction profile. The activation energy for a reaction must be met, otherwise the reaction will not take place. The second key term that we look at is the overall energy change. This is the difference between the energy that the reactants contained and the energy that the products contain. We work out the overall energy change by taking the energy in the reactants away from the energy in the products. A positive value for the overall energy change means that there is more energy in the products than there are in the reactants. This means that the reactant has taken in energy and therefore is an endothermic reaction. If the overall change is negative, it means that there is less energy in the products than there was in the reactants. This means that energy was given out in the reaction and therefore the reaction is an exothermic reaction. Let's now have a look at an endothermic reaction profile. On the reaction profile, you can see that a line goes straight across, then it rises and then it falls and then goes straight across again. The first straight line on the left is the energy that is in the reactants. The energy profile then rises, and this is because there needs to be an energy increase in the reactants in order for the reaction to take place. The difference between the energy in the reactants, which is the straight line on the left, and the top of the energy in the reaction profile is known as the activation energy. We can also see the overall energy change in the reaction profile. With the overall energy change, we're comparing the energy that is in the reactants with the energy that is in the products. For this reaction, you can see that the energy in the products is greater than the energy in the reactants. This means that this reaction is taking in energy and is therefore an endothermic reaction. An example of an endothermic reaction is photosynthesis. Photosynthesis is where water and carbon dioxide are reacted together to produce glucose and oxygen. The energy in the glucose and oxygen is greater than the energy in the carbon dioxide and water, and this is why it is an endothermic reaction. Light energy is needed for photosynthesis to happen. Let's now have a look at an exothermic reaction profile. Exothermic reactions give energy out to their surroundings. This energy is usually in the form of heat. As energy is given out, the energy of the products will be less than the energy of the reactants. This means that the overall change for an exothermic reaction is negative. We can also see on the reaction profile the activation energy that is required, and this is the energy that is needed to kick-start the reaction. An example of an exothermic reaction is respiration. When you exercise, your body is undertaking a great number of respiration reactions, which results in you becoming warm. This brings us to the end of this video. For more content, quizzes and past papers, go onto the website, which is www.elevise.co.uk.